We left off last episode with a modest power gain and 1.9 psi, a little bit disappointing, but also thoughts of picking up more psi in the future with a smaller supercharger pulley. Well, before installing that smaller supercharger pulley, in this episode I find a way to gain back about 1.5 psi, 15 horsepower, and that also will mean a much bigger upside when finally installing that smaller pulley. So stay tuned. Gonna do a real quick test for belt slip. So I've made a mark. The pulley is already engaged because the ignition's already on, and I figure I'm gonna take this for a short drive, get into boost a little bit, and then when it's time to stop the car, I think I'll just stall it so that the ignition stays on and the clutch stays engaged. Then inspect. Let's check out the state of the pulley. Wow, didn't slip at all. All right, well, that rules that out. So I'm thinking ahead to a future test I plan to run where I'm going to cap off my diverter valve. And if I notice that there's a significant amount of boost pressure loss, I'm going to want to replace it with something that seals better. So here is the Denso throttle body that actually came from the Forester. So this is the main throttle body for the car. And just to demonstrate it, I can send in some power, and we see it actuate and close. But there's always going to be this little gap, the sliver of light you see passing through, and that's just so that the car can idle. It's rare, if ever, that a car with an electronic throttle would want to fully shut, like so, because that would kill the engine. The engine needs at least a little bit of air to run. So what I'm looking to do is reconfigure this throttle so that in its resting state, it is fully shut. And to do that, I drilled out all the rivets holding the throttle position sensor and kind of this harness on. It's surprising how simple this is. All we got are the plus and minus for the motor, which you can use to send the motor forwards or into reverse. And all the rest of the electronics, so that's 2 of these pins, the first 2. The other 4 pins all relate to this, which is the throttle position sensor. So this detects the exact position of the throttle through probably some Hall effect sensors or something like that. But yeah, right off the bat I'm seeing if I move it into the closed direction, there's an adjustable stop to determine how far is closed. Then you see all of this gear movement, and there appears to be a pretty big spring to decide the stationary position. So I'm wondering what it will look like to reclock the sensor or the throttle blade to default to this position. It might involve taking something off, resetting the gear teeth or something along those lines. Okay, I think I found it. Didn't take very long. So when the throttle opens, there's this plastic stop that the spring catches, I guess, and that hits this adjustable screw. The screw, unfortunately, is very hard to get at. It's just encased in this kind of clear resin, so it might take a bit of careful dremeling or whatever to eat away at that until the screw is exposed. But then I think, yeah, just loosening that a little bit will change the position at which this stops, and then it can be fully shut. All right, so a drill bit made very short work of that resin, and now I can just put in a Torx or a hex bit and adjust its position, and you can see the entire throttle assembly turning towards a closed state. So now the throttle body is modified so that there is absolutely no gap. When we send 5 volts to it, it opens right up. It's not opening as quickly as it would if it was being powered with 12 volts. So to illustrate what it looks like when sent a 12 volt signal, The problem is it should really be a 12 volt PWM signal that passes just enough pulse width or duty cycle to get it open and no further. When you send it a 100% duty cycle 12 volt signal, it consumes almost 100 watts. So this would burn out in no time. So yeah, I'm going to look for a PWM controller and see if I can optimize this a bit. So here is a flange that should attach to the Subaru throttle body. I'll just need to braze together the two aluminum pieces. Alright, so I just finished brazing the flange onto this section of pipe. So the idea is that once the throttle body is bolted onto the bottom, it'll be the same length as the current bypass valve setup with the exhaust flanges. So yeah, I like how this turned out, and I've already cut the gasket, so I'm just waiting for it to cool. So I've yet to wire anything in, but here I've got the closed throttle plate replacing the old exhaust style bypass valve. As you can see, it's right next to its buddy, two Subaru throttle bodies. So I'm interested to see if I can reach more than 1.9 psi just in this state with the supercharger running. Alright, so new part installed. So far I've just been driving it with the supercharger off, which limits the manifold pressure quite significantly, probably because of the better seal. So here goes nothing, let's turn on the supercharger. Alright, and now when we floor it, 17.7, 17.2. I'm gonna drive around a little bit further and see if I can record kind of a steady state. Okay, so where it used to hang out at 16.2, it now fluctuates but hangs around 17.5. Alright, so I've adjusted the tune to account for the supercharger. The lower right is the air-fuel ratio, so if I floor it in NA mode, it goes down to mid to high 12s, and if I turn on the supercharger, making about 3 psi, it goes down to low 12s, high 11s, which is right where I want it to be. So I'm going to find a section of road and try to record a 0 to 60 run. Alright, found me an empty stretch of road. Let's do a quick 0 to 60. And moving on to how to actually get more than 3 psi. Here I have the Toyota, I think it's called like an SCS06 compressor. SCS06 made by Denso. So this compressor uses this pulley, and I'll be trying to replace the larger 113 millimeter pulley that the SC14 supercharger comes with. So just to compare the sizes of these things, here's the larger SC14 pulley magnet, and here's the smaller air conditioning compressor magnet. You can see it's a massive size difference, which will also mean that this probably draws less power and has less clamping force. So there's a risk of it slipping with this electromagnet. I'm going to say this is pretty close. I think if anything's in the way, it's this electrical connector. Okay, but angling it downwards, yeah, it almost has a place to go, but not quite. So I think that'll be the first challenge, is figuring out how to route the connector here. And then that just begs the question, does all of this fit kind of sandwiched together? Okay, so that's on. There's a couple threads exposed. It's almost like this is how it's supposed to be assembled. Obviously it's not, but yeah, this is with nothing but the electrical connector acting as the resistance here. I think this would actually work, with the last piece being the nut that holds the clutch onto this shaft. Cool. So yeah, this is going to be the next phase of the project with the smaller pulley. we should be seeing just over 7 psi of boost, which is going to be quite a big jump up from 3, more than I want, frankly. I'd like to step up to 5 psi next, but that is why I'm researching a replacement fuel pump, maybe replacement injectors, although I'm not sure yet what I'll find. So yeah, that should be all for this video. In the next one, I expect I'll be doing more of the actual wiring for that throttle plate that I installed. I've been thinking a lot about whether to install a sort of a kickdown switch, like a switch at the bottom of the gas pedal travel, which could, yeah, it could be just a fun kind of gimmicky way of turning it on only when you're at full throttle, which is most of the time that I'd want it to be on anyway. And then maybe just change my big on-off switch to maybe arm and disarm that feature, or just as an alternate way to like force it on or off or something along those lines. But yeah, thank you for watching.